Hello everyone. In the beginning of the class, please pause the video and review the following problems first. After you finish the following problems, you can continue the video and I will show you all my work in detail. Let's do the problems together. First one, 2x to the power 4 minus 3x squared minus 6 plus negative 3x to the power of 3 minus 7x squared minus 9. Then we try to eliminate the parentheses, then combine like terms. When there's nothing in the front, we can drop the parentheses without making any change. When we see addition in the front, we can also drop parentheses. Plus negative 3x to the power 3 minus 7x squared minus 9. Now when we see plus minus together, it means minus. Keep in mind that plus means plus. Minus double negative also means positive. Plus minus, it means minus. Minus plus also means minus. Keep the sign in mind. Then we try to combine like terms. When we combine like terms, we want a term with higher power come first. That's called descending order. We want a term with higher power come first. The term with highest power is 2x to the power of 4. Next, for power 3, there's only one term, negative 3x to the power of 3. Next, for x raised to power 2, we have two terms here. Negative 3x squared, negative 7x squared. When we combine like term, we try to add a coefficient. When we combine like term, follow addition rule, add a coefficient. Negative 3 plus negative 7. When we add in two numbers with the same sign, keep the sign and the magnitude. 3 plus 7 is 10. Like term x squared stays the same. Then can also combine negative 6 and negative 9. We also consider the numbers are like terms. Follow addition rule. When we are adding two numbers with the same sign, keep the sign and the magnitude. 9 plus 6, 6 plus 9 is 15. And that's the final answer. Next, 4xy squared minus 5x squared y minus a minus 6 minus 2x squared y plus 3xy squared. So same thing, we try to eliminate the parentheses first, then combine like terms. When there's nothing in the front, we drop the parentheses without making any change. When we see subtraction, we consider this is a negative sign. We distribute negative sign to each term in the parentheses. I have negative 6. Next, double negative is positive. Plus 2x squared y. Minus plus means minus 3xy squared. Then we combine like terms. Like term is the term with the same letters, same variable, same letters, raised to the same power. Here, 4xy squared and negative 3xy squared, they are like terms. They have exactly the same letter, raised to the same power, same variables, raised to the same power. So when we combine like terms, follow addition rule. When we add in two numbers with different sign, keep the sign for the number that has larger magnitude. Here, positive 4 has larger magnitude, so I keep positive sign. Then subtract the magnitude. 4 minus 3 is 1. Like term stays the same. xy squared stays the same. Another like term. 5x squared y and negative 5x squared y and positive 2x squared y, they are like term. They are like terms because they have the same power, same letter, raised to the same power. Then when you combine like term, if two numbers has different sign, keeping a sign from the number that has larger magnitude. Here, -5 has larger magnitude, so keep negative sign. Then subtract the magnitudes. 5 minus 2 is 3. Leave like term the same. X squared y, leave like term the same. Then we also consider the numbers. -6, -8, -6. We also consider numbers. -8, -6, they are like terms. Then combine like term. When we're adding two numbers with the same sign, keep the sign and the magnitude. A plus 6 is 14. In the first term, if it's positive, we don't write positive sign. And also, when the coefficient is 1, we don't write 1. So it can be rewritten as xy squared minus 3x squared y minus 14. Next, 5x minus 1 times 3 minus 4x. When we have two terms times two terms, we take each term in the first parenthesis, multiply to each term in the second parenthesis. Then let's distribute 5x first. 5x times 3 is 15x. 5x times -4x is -20x squared. Next, let me distribute -1. -1 times 3 is -3. -1 times -4x is positive 4x. Then combine like terms. When we combine like term, we want the term with higher power come first. So the term with the highest power is -20x squared. Next, we have 15x and 4x. 15x and 4x, they are like terms. When we combine like terms and the coefficient, 15 plus 4 is 19. Leave the like term the same. I get 19x. 15x plus 4x is 19x. And leave minus 3 the same. Next, 3x minus 2y times 4x plus y. When we have two polynomials multiplied together, we distribute every term in the first parenthesis to every term in the second parenthesis. So let's distribute 3x times 4x. 3 times 4 is 12. X times x is x squared. 3x times y, they cannot be multiplied, so I write it as 3xy. 3x times y, they cannot be multiplied, so I write it as 3xy. -2y times 4x, -2 times 4 is -a. Y times x is sy. Then -2y times y is -2y squared. Then we try to combine like terms. 3sy and -asy, they are like terms. We can try to combine these like terms together. When we combine like terms, follow addition rule. If two numbers have different sign, keep the sign from the number that has larger magnitude. So here, -a has larger magnitude. We keep negative sign. Then subtract the magnitudes. A minus 3 is 5. Leave the like term the same. Like term is sy. Leave it the same. Next, we keep the first term the same. Keep the last term the same. 12x squared minus 2y. 2y squared. Next, 2x minus 5 times 3x squared minus 4x plus 2. When we multiply two polynomials, we distribute every term in the first polynomial into the second term. So we first will take 2x multiplied to each term in the second parenthesis. Then we take -5 multiplied to each term in the second parenthesis. Let's distribute 2x first. 2x times 3x squared is 6x cubed. 2 times 3 is 6. X times x squared is x cubed. 2x times -4x. 2 times -4 is -a. x times x is x squared. 2x times 2 is 4x. Next, we distribute negative 5. Negative 5 times 3x squared is negative 15x squared. Negative 5 times negative 4x is positive 20x. Negative 5 times 2. Negative 5 times positive 2 is negative 10. Then we combine like terms. Distribute first, then combine like terms. When we combine like terms, we want a term with the higher power come first. Here, 6x cubed has the highest power. I leave it the same. Negative 8x squared and negative 15x squared, they are like terms. When we combine like terms, follow addition rule. If two terms have the same sign, keep the sign, add the magnitude. A plus 15 is 23. Like term is x squared, it stays the same. Another like term is 4x and 20x. When we combine like terms, 4x and 20x, when we combine like terms, follow addition rule. Keep the sign, add the magnitude. 4 plus 20 is 24. Like term is x, it stays the same. And another number is negative 10. There's no like term, it cannot be combined. So I leave it the way it is. That's the final answer. Next, 5x plus 4 raised to power 3. When we have 5x plus 4 raised to power 3, run the same thing 3 times. 5x plus 4 times 5x plus 4 times 5x plus 4. So when there are 3 polynomials multiplied together, we multiply the first 2 polynomials together first. Multiply the first 2 polynomials first. Then take the answer, multiply to the third polynomial. Let me multiply to here. Let me multiply the first 2 polynomials first. 5x plus 4 times 5x plus 4. When we have 2 terms times 2 terms, we distribute each term in the first parenthesis to each term in the second parenthesis. I first of all distribute 5x into the second parenthesis. Then I distribute 4 into the second parenthesis. 5x times 5x is 25x squared. 5x times 4 is 20x. Then distribute 4. 4 times 5x is 20x. 4 times 4 is 16. Then combine like terms. When we combine like terms, we want a term with the higher power come first. So we have 25x squared, that's the highest power. Next, we have 20x plus 20x. When we combine like terms, follow addition rule. When we adding two numbers with the same sign, keep the sign, add the magnitude. 20 plus 20 is 40. And the like term is x, I leave it the same. Last term is 16, it cannot be combined, I leave it the way it is. So, multiply first 2 parentheses, I get this. Multiply first 2 parentheses, I have 25x squared plus 40x plus 16. Leave last term the same. So when I multiply the first 2 parentheses, I get this. Put it here. Then I distribute each term in the first parenthesis into the second parenthesis. 25x squared times 5x. 25x squared times 5x. 25 times 5 is 125. X squared times x is x to the power of 3. 25x squared times 4. 25x squared times 4 is 100x squared. Next, distribute 40 into the second parenthesis. 40x times 5x. 40x times 5x is 200x squared. 40x times 4 is 160x. 40x times 4 is 160x. distribute 16 into the second parenthesis. 16 times 5 is 80. 16 times 5x is 80x. 16 times 4 is 64. Then we combine like terms. When we combine like term, we want a term with higher power come first. It's called descending order. The term with higher power come first. So here the highest power is 125x to the power of 3. Next, I can combine 100x squared with 200x squared. Combine like term, we have 300x squared. Next, we have 160x plus 80x, which is 240x. And the last term is 64. That's the final answer. Number 7. 4x plus 3y times 4x minus 3y. 4x plus 3y times 4x minus 3y. Let me remind you some formulas we learned last class. A plus b times a minus b, that always equal to a squared minus b squared. This formula is called the difference of perfect squares. This formula is called the difference of perfect squares. Another one is a plus b squared equal to a squared plus 2ab plus b squared. Next one, a minus b squared is a squared minus 2ab plus b squared. These two formulas together, they are called perfect square trinomials. They are called perfect square trinomials. Now, number 7. If we use this formula here, it looks like it matches the first formula, a plus b times a minus b. So according to the formula, it should be a squared minus b squared. If we treat 4x as a, 3y as b, I have 4x squared minus 3y squared. Then multiply out. 4 squared is 16. X squared stays the same as x squared. Minus 3 squared is 9. Y squared stays the same. Next, 3x squared minus 5 times 3x squared plus 5. And if we try to match the formula, you can see that this match the first formula. We have 3x squared minus 5 times 3x squared plus 5. The order doesn't matter. I can write plus first or I can write minus first. The order doesn't matter. It looks like it matched the first formula. A minus b times a plus b. So here we treat 3x squared as a. Treat number 5 as b. We have use the formula, we have a squared minus b squared. So we have 3x squared squared minus 5 squared. Three x squared squared, that's a squared, minus 5 squared, 5% b, so that's b squared. Then multiply out. 3 squared is 9. X squared squared, 2 times 2 is power 4. 2 times 2 is 4. Minus 5 squared. 5 squared means 5 times 5, which is 25. And that's the final answer. Next, 2x plus 3 times 2x minus 3 times 4x squared plus 9. 2x plus 3 times 2x minus 3 times 4x squared plus 9. If we multiply the first two terms, the first two polynomials, it looks like it matches this formula again. If we multiply the first two parentheses, it looks like it matches the first formula again. So here, 2x represents A, number 3 represents B. We have A plus B times A minus B. Then use the formula, we have A squared minus B squared. A squared minus B squared. 2x squared, 2 squared is 4. S squared is S squared. 3 squared is 9. We leave the second term the same. Bring it down. Now try to multiply these two polynomials. Now observe the formula again. It still looks like the first formula. 4x squared represents A. Number 9 represents B. We have A minus B times A plus B. Then use the formula again. Use the formula again. We have 4x squared minus 9 squared. A minus B times A plus B is A squared minus B squared. Then multiply out. 4 squared is 16. X squared 2 times 2 is 4. Minus 9 squared. 9 squared means 9 times 9, which is 81. Next. Half of x minus 6 times half of x plus 6 times a quarter of x squared plus 36. So we try to multiply the first two polynomials first. When there are 3 polynomials, we multiply the first two polynomials first. When I try to multiply the first two polynomials, it looks like they match the first formula here. A minus B times A plus B. If I treat half of x as A, I treat number 6 as B, I have A minus B times A plus B. If I use the formula, I have A squared minus B squared, which means half of x squared minus 6 squared. Put in bracket. Then square. Half square means half times half. Half square means half times half. Half times half. 1 times 1 is 1. 2 times 2 is 4. Half times half is a quarter. Times x squared minus 6 squared means 6 times 6 is 36. Then we keep the last parenthesis the same. Keep the last parenthesis the same. Bring it down. Now again, it still looks like the first formula. It still looks like the first formula. We have A minus B times A plus B. We still have A minus B times A plus B. So use the formula again. I have quarter x squared minus 36 squared. If I treat the first term as A, I treat the second term as B. That's all I have. A squared minus B squared. Then multiply. A quarter squared is what? A quarter times a quarter. Multiply top to the top, bottom to the bottom. 1 times 1 is 1. 4 times 4 is 16. I get 1 over 16. X squared is x raised to power 4. 2 times 2 is 4. Minus 36 squared. 36 squared, we take 36 multiplied by 36. 6 times 6 is 36, carry 3 over. 6 times 3 is 18. 18 plus 3 is 21. Write down 1, carry 2 over. Next, we multiply 3 to each of them. 3 times 6 is 18. Carry 1 over. 3 times 3 is 9. 9 plus 1 is 10. Write down 0, carry 1 over. Then adding up. Number 6 by itself is 6. 1 plus 8 is 9. 2 plus 0 is 2. Number 1 by itself is 9. So 36 squared is 1296. And that's the final answer. Number 11. 6x plus 1/3 of y square. If we observe this formula, we can see that it looks like the second formula, a plus b squared. If I treat 6x as a third of y squared as b, I have a plus b squared. So apply the third formula. We have 6x squared plus 2 times 6x times a third of y squared plus a third of y squared squared. It looks like this formula. We try to match. 6x represent a third of y squared represent b. I plug in 6x for a. I get 6x squared plus 2 times ab. A is 6x. B is 1/3 of y squared plus b squared. B is 1/3 of y squared and square outside, b squared. Then simplify. 6 squared is 36. X squared, I leave it the same. Next, 2 times 6x times a third of y squared. Multiply the numbers first. 2 times 6 times 1/3, what do we get? 2 times 6 times 1/3, what do we get? When we multiply whole number to fraction, we first rewrite the whole number as a fraction. Keep the fraction the same. Then when we multiply the top to the top, bottom to the bottom. 2 times 6 times 1. 2 times 6 is 12. 12 times 1 is 12. On the bottom, 1 times 1 times 3. 1 times 1 is 1. Then 1 times 3 is 3. 12 divided by 3 is 4. 12 divided by 3 is 4. So 2 times 6 times a third is 4. Then multiply the letters. X times y squared is xy squared. Last term, square. Distribute square to each of them. We have 1/3 of square times y squared squared. 1/3 square means 1/3 times 1/3. 1/3 times 1/3, we multiply 1, top to the top, bottom to the bottom. 1 times 1 is 1. 3 times 3 is 9. We have 1 over 9. 1/3 square is 1 over 9. Y squared squared is y raised to power 4, because 2 times 2 is 4. Next. Two x squared y minus a quarter z to the power 3 squared. 2x squared y minus a quarter z to the power 3 squared. If you try to match the formula, it looks like the third one. It looks like this is a, this is b. We have a minus b squared. So 2s squared y represent a. A quarter z cubed represent b. So use the formula, we have a squared minus 2ab plus b squared, which is 2x squared y squared minus 2 times 2x squared y times a quarter of z cubed plus a quarter of z cube square. Try to use the formula here. A square minus 2ab, 2 times ab plus b square. A square minus 2 times ab plus b square. Then simplify each term individually. First term, 2 square is 4. X square square is power 4. 2 times 2 is 4. And times y square. Second term, minus 2 times 2 times a quarter. Multiply the numbers first. Multiply the numbers first, then multiply the variables. Multiply numbers first. 2 times 2 times a quarter. 2 times 2 times a quarter. When we multiply whole number to fraction, we first of all put the whole number over 1, write it as a fraction first. Then we multiply the top to the top, bottom to the bottom. So on the top, 2 times 2 is 4. 4 times 1 is 4. On the bottom, 1 times 1 is 1. 1 times 4 is 4. 4 over 4. 4 divided by 4 is 1. We have 1. Then multiply the letter together. X squared times y times z cube. That's x squared y z cube. Multiply the letter together. X squared times y times z cube. That's the second term. And usually we know that if the coefficient is 1, we don't write 1. If the coefficient is 1, we don't write 1. So write it as x squared y z cube. Last term, distribute square to each of them. A quarter square means a quarter times a quarter. We multiply the top to the top, bottom to the bottom. So 1 times 1 is 1, 4 times 4 is 16. And for z cube, if I distribute square, I multiply 2 to power 3. 2 times 3 is 6. Z to the power 6. And that's the formula. That's the final answer if we use the formula. Next. (12x to the power 3, y to the power 5) minus 18x to the power 7, y to the power 6 plus 24 x to the power 5, y to the power 4 over 6x cubed, y to the power 4. When we have multiple terms, divide by one term. We take each term on the top, divide by the term on the bottom. Take each term on the top, divide by the term on the bottom. So I have 12 x to the power 3, y to the power 5 over 6x to the power 3, y to the power 4 minus 18x to the power 7, y to the power 6 over 6x to the power 3, y to the power 4 plus 24x to the power 5, y to the power 4 over 6x to the power 3, y to the power 4. When we have multiple terms, divide by one term. We take each term on the top, divide by the term on the bottom. Then we divide each term individually. First term, 12 divided by 6 is 2. X cubed divided by x cubed, they get cancelled completely. If they have exactly the same power, they get cancelled completely. Y to the power 5 divided by y to the power 4. When you divide, subtract the power. 5 minus 4 is 1. And in general, if the power is 1, we don't write 1. If the power is 1, we don't write 1. So we write 2y. That's the first term. Second term, 18 divided by 6 is 3. X to the power 7 divided by x to the power 3. When you divide, Saturn power. 7 minus 3 is 4. And for y's, y to the power 6 divided by y to the power 4. When you divide Saturn powers, 6 minus 4 is 2. Last term, 24 divided by 6. 24 divided by 6 is 4. X to the power 5 divided by x to the power 3. Subtract. When you divide Saturn power, 5 minus 3 is 2. Last part, y to the power 4 looks exactly the same on the top and the bottom, so they get cancelled completely. Nothing left, no y left here. So that's your final answer. Next, 27 x to the power 6 y to the power 4 minus 18 x to the power 5 y to the power 7 minus 36 x to the power 6 y to the power of 5. Divide by negative 9 x to the power 4 y to the power 3. When we have multiple terms, divide by one term on the bottom. We take each term on the top, divide by the term on the bottom. We split the top, take each term on the top, divide by the term on the bottom. So I have 27 x to the power 6 y to the power 4 divided by negative 9 x to the power 6 y to the power 3 minus 18 x to the power 5 y to the power 7 divided by negative 9 x to the power 4 y to the power 3 minus 36 x to the power 6 y to the power 5 divided by negative 9 x to the power 4 y to the power of 3. So let's divide. We simplify each term individually. First term, positive 27 divided by negative 9 is negative 3. Positive 27 divided by negative 9 is negative 3. X to the power 6 divided by x to the power 4. When you divide, subtract the power. 6 minus 4 is 2. Next, y to the power 4 divided by y to the power 3. When you divide, subtract the power. 4 minus 3 is 1. And in general, when the power is 1, we don't write 1. If the power is 1, we don't write 1. Next term, negative 18 divided by negative 9. Negative 18 divided by negative 9 is positive 2. Double negative is positive. Negative 18 divided by negative 9 is positive 2. X to the power 5 divided by x to the power 4. When you divide, subtract the power. 5 minus 4 is 1. If the power is 1, we don't write 1. In general, if the power is 1, we don't write 1. Last part. Y to the power 7 divided by y to the power 3. When you divide, subtract the power. 7 minus 3 is 4. So you get y to the power of 4. Next term. Negative 36 divided by negative 9. Double negative is positive. 36 divided by 9 is 4. Then x to the power 6 divided by x to the power 4. When we divide, subtract the power. 6 minus 4 is 2. Y to the power 5 divided by y to the power 3. When we divide, subtract the power. 5 minus 3 is 2. And that's the final answer. So that's what we learned last class. Today we will study factoring. What is called factoring? Let's look at all example first. Let's look at all example first. How do we multiply this? 2x times 3x plus 4. When we multiply 2x to these parentheses, I multiply 2x to each term in the parentheses. I distribute 2x to each term in the parentheses. 2x times 3x squared is 6x to the power of 3. 2x times 4 is ax. The operation from left to right, that's what we learned last class. Operation from left to right is called multiplication. Operation from left to right is called multiplication. If we try to go backward, that's called factorization. If we try to go backward, this operation is called factorization. So today we will study how to do factoring. So for factoring, I will first of all show you taking out greatest common factors. First way to factor is called taking out common factors, greatest common factors. First way to do factoring is called taking out greatest common factor. That first method to factor is called taking out the greatest common factor. Taking out the greatest common factors. That's the first way to factor. That's the first method to factor. It's called taking out the greatest common factor. Greatest common factor is called the GCF. Greatest common factor is also called a GCF. First of all, let me introduce what's the GCF. GCF, greatest common factor of polynomial, is the greatest common factor of the coefficients. The greatest common factor of the coefficients followed by the common letters, common variables. It's the greatest common factor of the coefficients followed by the common variables. Raised to the lowest power. Raised to the lowest power. Let me show you some example. Greatest common factor of a polynomial is the greatest common factor of the coefficients followed by the common variables raised to the lowest power. Let's look at some simple example first. Find the greatest common factor. First example. Suppose I give you 10 and 20. What's the greatest common factor? For 10 and 20, the greatest common factor is 10, because I can divide both numbers by 10 evenly. So the greatest common factor is 10. I can divide both numbers by 10 evenly. That's called the greatest common factor. If I give you A and 18, what's the greatest common factor? I can divide both numbers by 2 evenly. That's called the greatest common factor. I can divide both numbers by 2 evenly. For A and 18, I can divide both numbers by 2 evenly. So that's called the greatest common factor. X to the power 4 and x to x to the power 6, x to the power 4, and x to the power 6. The common letter is x. The common variable is x. And I choose the lowest power. Lowest power is 4. So x raised to the lowest power. Common letter is x. Lowest power is 4. Another example. Y to the power 2, y to the power 5, y to the power 3. If I give you 3 terms, what's the greatest common factor? Common letter is y. I choose the lowest power. Lowest power is y to the power of 2. Common letter is y. I choose the lowest power. Lowest power is 2. Next. Fifteen x to the power 4 and 10x squared y to the power 3. What's the greatest common factor? For 15 and 10, look at the number first. For 15 and 10, I can divide both numbers by 5. So 5 is the greatest common factor for 15 and 10. The largest possible number I can divide is 5. The largest possible number I can divide for both numbers. The largest possible number I can divide is 5. So 5 is the greatest common factor. Now, common letter here, they both contain letters. Common letter is x. Common letter is x. Common letter is x. I choose the lower power. Lower power is 2. Lowest power is 2. Common letter is x. I choose the lowest power. Y is not common. Y is not a common letter, so it doesn't count. Since y is not common, it doesn't count. Next. Negative 21 xy, comma 6y to the power of 4. What's the greatest common factor? When we are looking for the greatest common factor, we don't care about the sign. We don't care about it's positive or negative. When we are looking for the greatest common factor, we don't care about the sign. We don't care if it's positive or negative. Look at the number first. For 21 and 6, the largest possible number I can divide is 3. For 21 and 6, the largest number I'm allowed to divide is 6. The largest number I'm allowed to divide is 3. I can't divide by 6. 21 divided by 6, I don't get whole number. If I use 21 divided by 6, I don't get whole number. And the largest number I'm allowed to divide is 3. That's the greatest common factor from the numbers. Now here, common letter here is y. And I choose the lowest power. Y by itself, power is 1. Y is lower than 4. So I choose the lowest power. 3y to the power 1. For the final answer, if the power is 1, we don't write 1. So that's the greatest common factor. M squared n, 24 m to the power 5 n, and 18 m to the power 3 n to the power 2. What's the greatest common factor? Look at the number first. 12, 24, and 18. The largest possible number that I'm allowed to divide is 6. For all these 3 numbers, the largest number I'm allowed to divide is 6. 12 divided by 6 is a whole number. 24 divided by 6 is 4, that's a whole number. 18 divided by 6 is 3, that's also a whole number. So the largest number I'm allowed to divide is 6. That's the greatest common factor of the number. That's the greatest common factor of the coefficient. Then we pick the common letter raised to the lowest power. M is common. m is common. And choose common letter raised to the lowest power. Here, lowest power is power 2 for m, for letter m. Lowest power is power 2. Now, letter n is also common here. In this example, letter n is also common. Letter n is also common. Lowest power here is 1. m by itself power is 1. 1 is less than 2. So lowest power is 1. And if the power is 1, we don't write 1. So the final answer is 6m squared times n. Next. 28 to the power 3 b squared c, comma, negative 15 a b to the power 4, comma, 35 a to the power 5 b to the power 8 c to the power 4. What's the greatest common factor? Look at the numbers first. 20, 15, 35. When we look at the number, we don't care about the sign. When we find the greatest common factor, we don't care about the sign. Look at 20, 15, 35. The largest number that I'm allowed to divide. For all three numbers, the largest number I'm allowed to divide is 5. The largest number I'm allowed to divide is 5. 20 divided by 5 is 4. 15 divided by 5 is 3. 37 divided by 5 is 7. The largest number I'm allowed to divide is 5. Common letter is, letter A is common. Letter A is common. For letter A, lowest power is power 1. If there's no power, power is 1. And if the power is 1, we don't write 1. Lowest power is power 1, we don't write 1. We don't write power 1. Letter A is common. What else is common? Letter B is common. And for letter B, we choose the lowest power. For letter B, the lowest power is power 2. For letter B, lowest power is power 2. Anything else common? Letter C is not common because there's no C in the middle term. Letter C is not common, so it doesn't count. So we have common letter raised to the lowest power. We only use common letter raised to the lowest power. That's how we find the greatest common factor of a polynomial. We first of all find the greatest common factor from the numbers first. Then we find the common letter raised to the lowest power. We first of all find the greatest common factor from the numbers first. For 20, 15, 35, greatest common factor is 5 because that's the largest number that we are allowed to divide for these three numbers. Then pick the common letter. A is common, B is common. Then we choose common letter raised to the lowest power. For letter A, lowest power is power 1. For letter B, lowest power is power 2. That's how we find the greatest common factor. Next, I'll show you the first method of factoring. Factoring by taking out the greatest common factor. Next, I'll show you the first method of factoring. Factoring by taking out the greatest common factor. Look at first simple example first. Look at simple example first. 25x to the power 6 plus 10x to the power 2. So when there are multiple terms and we try to factoring by taking out the greatest common factor, look at the numbers first. For 25 and 10, the largest number we are allowed to divide is 5. The largest number we are allowed to divide is 5. Then the common letter here is x. The common letter is x. We choose the lowest power. Lowest power is 2. Then let's first of all we write the greatest common factor in the front. Then put the rest in the parentheses. For the rest, 25 divided by 5 is 5. 25 divided by 5 is 5. First term, we have x to the power 6. That means there are 6x multiplied together. If I take out 2 of them, we have 4x left inside. X raised to the power 6 means there are 6x multiplied together. If I take out 2 of them, that means there are 4 more stays inside the parentheses. Next term, 10 divided by 5 is 2. 10 divided by 5 is 2. 10x squared means we have 2x multiplied together. If I take out 2 of them, there's no x left. For x squared, if I take out x squared, there's nothing left. X squared means there are 2x multiplied together. If I take out 2 of them, there's nothing left. So second term becomes 2. That's how we factoring by taking out the common factor, the greatest common factor. Another example, 18n to the power 3 minus 6n. We first of all find the greatest common factor for the numbers. For 18 and 6, the largest number that I'm allowed to divide is 6. Common letter is letter n. Then we choose the lowest power, power 3 and power 1. If there's no power, also the power is 1. For power 3 and power 1, the lowest power is power 1. So we have 6n, that's the greatest common factor. Next, 18 divided by 6 is 3. 18 divided by 6 is 3. N to the power 3 means there are 3 n's multiplied together. If I take out one of them, another 2 left here. 18 n to the power 3, that means there are 3 n's multiplied together. If I take out one of them, there are 2 more left inside. Second term, 6 divided by 6 is 1. There's only one n here. If I take out n, there's no letter left. So the second term is 1. That's the final answer. Next example, 21x to the power 3 minus 7x squared y. First of all, we find the common factor for 21 and 7. For 21 and 7, the largest number that I'm allowed to divide is 7. And then next, look at the common letter. The common letter is x, and lowest power for x is power 2. Then we try to take on a common factor. 21 divided by 7 is 3. X raised to power 3 means there are 3x. If I take out 2 of them, there's one more x left inside the parentheses. For the second term, 7 divided by 7 is 1. X squared means there are 2x multiplied together. If I take out 2x, there's no x left. There are 2x. If I take out x squared means I take out 2x, there's no x left. What's left is letter y. Now, for your final answer, if the coefficient is 1, we don't write 1. For the final answer, if the coefficient is 1, we don't write 1. For the final answer, if the coefficient is 1, we don't write 1. Next, 5x squared minus 7x to the power 5. 5x squared minus 7x to the power 5. For 5 and 7, what's the greatest common factor? For 5 and 7, the greatest common factor is 1. That's the largest number that I'm allowed to divide for both numbers. That's the largest number that I can divide. Then common letter is x. Lowest power is power 2. Now, if the coefficient is 1 for any term, if the coefficient is 1, we don't write 1. If the coefficient is 1, we don't write 1. Now, 5x squared, that means there are 2x multiplied together. If I take out x squared, there's no x left. What's left is number 5. Next term, 7 stays the same. X to the power of 5 means there are 5x multiplied together. There are 5x multiplied together. If I take out 2 of them, there are 3 more x left. That's the final answer. Next example, 6x to the 6y to the power of 7 plus y to the power of 4. Take out common factor first. Since there's no number here, we don't take out common factor for numbers. Only look at the variables, the letters. Only look at the letters. Letter y is a common factor. The lowest power is power 4. First term, number 6 stays the same. Y to the power 7 means there are 7 y's multiplied together. If I take out 4 of them, there are 3 more left here. Second term, y to the power 4. That means there are 4 y's multiplied together. If I take out 4 y's, there's nothing left. But if there's nothing left, we cannot leave it blank. When we're doing factoring, if there's nothing left, we cannot leave it blank. We write number 1 as a placeholder. If there's nothing left, we cannot leave this place blank. We write number 1 here as a placeholder. Number 6. 18xy to the power 4 minus 2y minus 4x squared y. 18xy to the power 4 minus 2y minus 4x squared y. So take on a common factor. Look at the numbers 18, 2, and 4. The greatest common factor is 2. That's the largest number that I'm allowed to divide for each numbers. That's the largest number that I'm allowed to divide. Common letter, x is not common. Y is common. Lowest power for letter y, lowest power is power 1. If there's no power, power is 1. So lowest for letter y, lowest power is power 1. If I pull out 2y, 18 divided by 2 is 9. Since I only pull out y, x stays there. Since I only pull out y, this x stays there. Y to the power 4 means there are 4 y's. If I pull out one of them, there are 3 more left. For the second term, 2 divided by 2 is 1. There's only 1 y. If I take out y, there's no y left. Last term, 4 divided by 2 is 2. Since I only take out y, x stays here. So x squared stays here. There's only 1 y. If I pull out y, there's no y left. So that's the final answer. Next. 15a squared b to the power 3 minus 20 a to the power 5 b to the power 4 plus 30 a to the power 3 b to the power 2. So first of all, we find a common factor for the numbers 15, 20, 30. The common factor is 5. That's the largest number I'm allowed to divide for all 3 numbers. That's the largest number that I'm allowed to divide. common letter. Letter A is common. Letter A is common. For letter A, the lowest power is power 2. Another common letter is letter B. Letter B is also common. The lowest power for letter B is power 2. What's left here? Take 15 divided by 5 is 3. A to the power 2 means there are 2 A's. If I take out 2 A's, there's no A left. B to the power 3 means there are 3 B's. If I take out 2B, there's 1 B left. Second term, 20 divided by 5 is 4. A to the power 5 means there are 5 A's. If I take out 2 of them, there are 3 more left. B to the power 4 means there are 4 B's multiplied together. If I take out 2 of them, there's another 2 left here. Next, 30 divided by 5 is 6. A to the power 3 means there are 3 A's multiplied together. If I take out 2 of them, there's 1 more left. B to the power 2 means there are 2 B's multiplied together. If I take out 2 of them, there's no B left. So that's an answer. Next, 7xy plus 49 x to the power 4 y to the power 3 minus 21y squared. 7xy plus 49 x to the power 4 y to the power 3 minus 21y squared. First of all, we take out the greatest common factor. For the numbers 7, 49, 21, the greatest common factor is 7. That's the largest number that I can divide. That's the largest number that I'm allowed to divide. Common letter, x is not common. There's no x in the last term. Only y is common. Lowest power is power 1. So pull out 7y. For the first term, 7 divided by 7 is 1. X stays there. Since I only take out y, x stays there. There's only 1y. If I take out 1y, there's no y left. Second term, 49 divided by 7 is 7. I take out 1y, so x to the power 4 stays the same. There are 3 y's here. There are 3 y multiplied together. If I take out one of them, there are 2 more left. Last term, 21 divided by 7 is 3. Y squared means there are 2 y's multiplied together. If I pull out one of them, another one left here. Now, for the final answer, if the coefficient is 1, we don't write 1. For the final answer, if the coefficient is 1, we don't write 1. So that's the final answer. Number 9. Negative 14xy minus 6y squared. Negative 14xy minus 6y squared. First of all, try to find the greatest common factor. For 14 and 6, the greatest common factor is 2. For 14 and 6, the greatest common factor is 2. That's the largest number I'm allowed to divide. For 14 and 6, number 2 is the largest number that I'm allowed to divide. Then common letter is y. Common letter is y. For letter y, lower power is power 1. Lower power is 1. So 2y is the common factor. 2y is the greatest common factor. Now, for factoring, there's a rule. It says, if the first term is negative, we must pull out negative sign. For factoring, there's a rule. It says, if the first term is negative, we must pull out negative sign. If the first term is negative, we must pull out negative sign. So I pull out negative 2y. Now, if I pull out negative 2y, negative 14 divided by -2, it becomes positive 7. -14 divided by -2 is positive 7. If I pull out 1y, x stays there. Now for the second term, be very careful. We treat -6 as -6. We treat -6 as -6. -6 divided by -2 is positive 3. -6 divided by -2 is positive 3. Y squared means there are two y's multiplied together. If I pull out one of them, another one left here. So that's the final answer. Next. -4x squared minus plus 4x minus 16x to the power 4. -4x squared plus 4x minus 16 to the power of 4. First of all, we find a common factor for the numbers. For 4, 4, and 16, the greatest common factor is 4. That's the largest number that I'm allowed to divide for all these three terms. That's the largest number that I'm allowed to divide. So that's the greatest common factor. For letters, common letter here is x. Common letter is x, so I pull out x. Then choose the lowest power. We have power 2, power 1, power 4. Lowest power is power 1. Now, for factoring, if the first term is negative, we need to pull out negative sign. If the first term is negative, we want to pull out negative sign. So for the first term, if I pull out -4x, -4 divided by -4 is positive 1. -4 divided by -4 is positive 1. X squared means there are two x multiplied together. If I pull out one of them, the other one left here. Second term, if I pull out -4, I treat this as positive 4. I treat plus 4 as positive 4. Positive 4 divided by -4. Positive 4 divided by -4 is -1. Positive 4 divided by -4 is -1. That's only one x. If I pull out x, there's no x left here. That's the second term. Third term, I treat -16 as -16. For the third term, I treat -16 as -16. -16 divided by -4 is positive 4. X raised to power 4 means there are 4x multiplied together. If I pull out one of them, we have 3x left. X to the power 4 means there are 4x multiplied together. If I pull out one of them, there are 3 more left here. Now, for the final answer, if the coefficient is 1, we don't write 1. For the final answer, if the coefficient is 1, we don't write 1. So 1x is the same as x. Next, 4x times 3x plus 2 minus 3 times 3x plus 2. Now, that's a little different. Observe these two parts. We can see that 3x plus 2 is a common factor. This part looks exactly the same. 3x plus 2 looks exactly the same. We can consider this is a common factor. If I pull it outside, if I pull out 3x plus 2, what's left is 4x minus 3. If I pull out 3x plus 2, what's left is 4x minus 3. If I pull out what's common, what's left is 4x minus 3. That's a very special one. Next. 7a times x minus 2y plus 5 times x minus 2y. 7a times x minus 2y plus 5 times x minus 2y. If we observe these two parts, we can see that x minus 2y is a common factor. X minus 2y is a common factor. If I pull out x minus 2y, what's left is 7a plus 5. Next. Five y times x plus 3 minus x plus 3. 5y times x plus 3 minus x plus 3. If you observe these two terms, we can see that what's common is x plus 3. What's common is x plus 3. If I pull out x plus 3, if I pull out what's common, what's left is 5y minus, what's left is 5y minus what? For the first time I pull out x plus 3, what's left is 5y. Keep subtraction. For the second term, if I pull out x minus 3, if there's nothing left, I cannot leave it blank. I write 1 as a placeholder. If I take out x minus 3 and there's nothing left, I cannot leave this place blank. I write 1 here as a placeholder. We cannot leave this place blank. If we take out everything completely and there's nothing left, we write 1 as a placeholder. And that's the final answer. Next. 2x times x plus 4 minus 3 times x plus 4. If we observe these two terms, we can see that x plus 4 is a common factor. If I pull it outside, if I pull out x plus 4, what's left is 2x minus 3. That's the final answer. Next example. 4y squared times x squared plus 1 minus 2y times x squared plus 1. Four y squared times x squared plus 1 minus 2y times x squared plus 1. If we observe these two terms, we can see that x squared plus 1 looks exactly the same. X squared plus 1 looks exactly the same. We can pull it outside first. If I pull out x squared plus 1, what's left is 4y squared minus 2y. 4y squared minus 2y. Now, be very careful. Be very careful, especially when you see some power other than 1. Be very careful. Look at the first term, x squared plus 1. Is there any common factor? There's x in the first term, but there's no x in the second term, so there's no common factor. In the first parenthesis, there's no common factor. We can leave it the way it is. In the second parenthesis, do you see common factors? I leave first parenthesis the way it is. In the second parenthesis, do you see any common factors? In the second parenthesis, do you see any common factors? 4y squared minus 2y. For number 4 and number 2, 2 is a common factor. 2 is a number that we are allowed to divide. 2 is the largest number that we are allowed to divide. Common letter is y. For y squared and y, common letter is y. Lowest power is power 1. If I pull out 2y, 4 divided by 2 is 2. For y squared, there are two y's multiplied together. If I pull out one of them, another y left here. Second term, 2 divided by 2 is 1. There's only one y. If I pull out y, there's nothing left. So for the final answer, I write this term in the front. Since this is outside the parentheses, I put it in the front. Put it all the way to the front. This is outside the parentheses. I put it all the way to the front. So for final answer, I write 2y s squared plus 1 times 2y minus 1. This is completely outside the parentheses. I put everything outside the parentheses all the way in the front. That's the final answer. Next, 6x squared times s plus 1 plus 3x to the power 4 times s plus 1. 6x squared times s plus 1 plus 3x to the power 4 times x plus 1. So first of all, we see that in both terms, s plus 1 is a common factor. S plus 1 is a common factor. I can first of all pull out s plus 1. If I pull out s plus 1, what's left is 6x squared plus 3x to the power 4. If I pull out s plus 1, what's left is 6x squared plus 3x to the power 4. Now observe, do we have any other common factors? In the first parenthesis, s plus 1, there's no common factor. In the second parenthesis, since there's no common factor, I leave it the same. In the second parenthesis, 6s squared plus 3x to the power 4. Do you see any common factor here? For 6 and 3, the greatest common factor is 3. That's the largest number that I'm allowed to divide for both numbers. Do you see any common letter? S is common. And we choose the lowest power. For 2 and 4, lowest power is 2. Pull out 3s to the power 2. What's left is 6 divided by 3 is 2. S squared means there's only 2x. If I pull out s squared, if I pull out 2x, there's nothing left. S squared means there are 2x multiplied together. If I pull out s squared, no more x left. Second term, 3 divided by 3 is 1. X to the power 4 means there are 4x multiplied together. If I pull out 2 of them, there's another 2 left. Then for the final answer, we see that 3x squared, that's outside the parentheses. When you see something outside the parentheses, put it all the way to the front. When you see something outside the parentheses, put it all the way to the front. We have 3x squared. What's left is x plus 1 times 2 plus 1x squared. If the coefficient is 1, for any term, if the coefficient is 1, we don't write 1. We write 2 plus x squared. So that's the final answer. Next, 3y times a minus b plus 4 times b minus a. 3y times a minus b plus 4 times b minus a. Now these two terms, they look almost the same, but a little different. They look almost the same, but a little different. First term is a minus b. Second term is b minus a. What should we do? Now be very, very careful. Keep one thing in mind. A plus b is always the same as b plus a. For addition, if you switch order, it makes no difference. For addition, if you switch order, it makes no difference. But a minus b is not the same as b minus a. They are not the same. For subtraction, you can switch orders. For addition, if you switch order, it makes no difference. For subtraction, you can switch orders. Be very, very careful. For subtraction, you can switch orders. 10 minus 3 is 7. And what's 3 minus 10? 10 minus 3 is 7. What's 3 minus 10? We consider combining like terms. Positive 3, negative 10. Positive 3, negative 10. When we're adding two numbers with different sign, keeping the sign from the number has larger magnitude. Here, negative 10 has larger magnitude. Keep negative sign. Then subtract the magnitude. 10 minus 3 is 7. Another example. 12 minus 6. It's 6. 12 minus 6 is 6. How about 6 minus 12? We can't subtract directly, so we need to consider their like terms. Try to combine like terms. Positive 6 and negative 12. We try to combine positive 6 and negative 12. When we combine two numbers with different sign, keep the sign from the number that has larger magnitude. Here, negative 12 has larger magnitude. Keep negative sign. Then subtract the magnitude. 12 minus 6 is 6. So we can see that for subtraction, if I switch order, value is the same, but the sign change. If I switch order, 10 minus 3 and 3 minus 10, value is the same, but the sign changed. Value is the same, but the sign changed. So we know that A minus B is not the same as B minus A, but that equal A minus B equal to negative B minus A. If I switch order, the sign change. If I switch order for subtraction, the sign changed. So keep this in mind. For subtraction, if I switch order, the sign changed. So for number 17, in the second part, if I switch order here, if I switch order, the sign changed. Positive 4 become negative 4. If I switch order, the sign changed. Positive 4 become negative 4. I leave the first term the same. Now we can see that A minus B is the common factor. Pull it outside. If I pull out A minus B, what's left is 3y minus 4. So be very careful. Next. X times x minus 9 minus 3 times 9 minus x. X times x minus 9 minus 3 times 9 minus x. What should we do here? We see that x minus 9 and 9 minus x, they look almost the same, but a little different. They have different order. If I switch order, the sign changed. For subtraction, if I switch order, the sign will be changed. So if I switch order, if I make 9 minus x to be x minus 9, the sign will be changed. Negative 3 become positive 3. If I switch order, the sign will be changed. I leave the first term the same. Then we see that x minus 9 is a common factor. I can pull it outside. X minus 9 is a common factor. I can pull it outside. If I pull out x minus 9, what's left is x plus 3. If I pull out x minus 9, what's left is x plus 3. Next example, 4x times x minus 1 minus 1 minus x. 4x times x minus 1 minus 1 minus x. If we compare these two terms, we can see that x minus 1 and 1 minus x, they are almost the same, but they have opposite orders. X minus 1, 1 minus x has opposite order. If I switch order, the sign will be changed. Negative sign become positive sign. I leave the first term, the first part the same. Then we can see that x minus 1 is a common factor. s minus 1 is a common factor. If I pull out s minus 1, what's left is 4x plus what? 4x plus. If there's nothing left, when I pull out common factor, if there's nothing left, we cannot leave it blank. We need to write 1 as a placeholder. If I take out common factor and there's nothing left, I cannot leave it blank. I must write 1 as a placeholder. That's the final answer. Next, (10a squared x minus 4 minus 6a 4 minus x). If I observe these two terms, s minus 4 and 4 minus x, they almost look the same. But s minus 4 and 4 minus x has different order. So if I switch order for a polynomial with subtraction in the middle, I need to change the sign. So negative 6a become positive 6a. I leave first term the same. Then I can pull out common factor. S minus 4 is common, I can pull it outside. Pull out s minus 4, what's left is 10a squared plus 6a. But be careful, we are not done. Be careful. For x minus 4, first part s minus 4, there's no common factor, I leave it the way it is. For the second term, 10a squared plus 6a. For 10 and 6, common factor is 2. Greatest common factor is 2. That's the largest number that I'm allowed to divide. For both numbers, that's the largest number I'm allowed to divide. Common letter is letter A, and choose the lowest power. Lowest power is 1. If I pull out 2a, 10 divided by 2 is 5. A squared means there are 2 a's. If I pull out one of them, another one left here. 6 divided by 2 is 3. There's only one a. If I pull out a, there's no a left. Then, since 2a is outside the parentheses, for the final answer, I put it in the front. 2a is outside the parentheses. For the final answer, I put it in the front. So the final answer, I have 2a. The final answer, 2a times s minus 4 times 5a plus 3. That's the final answer. Next example. xy minus 4x plus 3y minus 12. Do we see any common factors here? There's no common factor for numbers. For letters, x is not common. Y is also not common. So there's no common factor here. What should we do? When there are 4 terms, if I group the first 2 terms together and group the last 2 terms together, if I fit on the first 2 terms, what do we get? If I fit on the first 2 terms, I can pull out x. X is common factor. If I pull out x, what's left is y minus 4. That's the first 2 terms. For the last 2 terms, for 3y and 12, 3 is a common factor. I can pull out 3. Y is not a common factor. I cannot pull out y. If I pull out 3, 3y divided by 3 is 1. Y stays the same. 12 divided by 3 is 4. And 1y is the same as y. Then we can see that y minus 4 looks exactly the same. For these 2 terms, y minus 4 looks exactly the same. If I pull out y minus 4, what's left is x plus 3. What's left is x plus 3. This technique is called factoring by grouping. This new technique is called factoring by grouping. Factoring by grouping. We group two terms together, group the first two terms together, and group the last two terms together. Factor each part individually, then combine together at the end. Another example. (4b minus 20 plus ab minus 5a). 4b minus 20 plus ab minus 5a. Again, if I look at these four terms, there are no common factors. So I can factor two of them at a time. We can factor two of them at a time. If I group the first two terms together and group the last two terms together, factor each part individually. For the first two terms, 4b minus 20. Number 4 is the greatest common factor. 4 is the largest number that we are allowed to divide for 4 and 20. Then for the first term, 4b, 4 divided by 4 is 1. Letter b stays the same. Second term, 20 divided by 4 is 5. So we get 1b minus 5. If the coefficient is 1, we don't write 1. In general, if the coefficient is 1, we don't write 1. So we write b minus 5. Second half. ab minus 5b, we can see that a is the common letter. It's called common factor. If I pull out letter a, ab become b. If I pull out letter a, 5a become 5. Now we see that b minus 5 is a common factor. b minus 5 is a common factor. If I pull out b minus 5, what's left is 4 plus a. Another example. 6h minus 6k minus h squared plus hk. 6h minus 6k minus h squared plus hk. When we have four terms, we factor by grouping. When there are four terms, we factor by grouping. If I group the first two terms together, we can see that 6 is a common factor. Pull it outside. If I pull out 6, I have h minus k. If I pull out 6, 6 divided by 6 is 1. 1h is the same as h. Second part, 6 divided by 6 is 1. 1k is the same as k. Second half. In the second half, we see that the first term is negative. In the second half, the first term is negative. Be very, very careful here. For h squared and h is the common factor. We choose the lowest power for h. H by itself, power is 1. So I pull out h to the power 1. For the second half, since the first term is negative, we pull out negative sign. H squared means there are two h multiplied together. If I pull out one of an h, I have h left. Now second term, we have positive hk. If I pull out negative h, positive divided by negative is negative. If I pull out negative h, positive divided by negative is negative. I pull out h, what's left is k. Then we see that h minus k is a common factor. If I pull out h minus k, what's left is 6 minus h. Next example. X to the power 3 plus x squared plus x plus 1. So if there are four terms, we group two of them together. We group the first two terms together, and we group the last two terms together. For the first two terms, if I try to factor the first two terms, x to the power 3 plus x squared. Common factor is x. I choose the lowest power, For x to the power 3 and x squared, lowest power is power 2. If I pull out x squared, x cubed means there are 3x multiplied together. If I pull out 2 of them, there's one more x left here. Second half, x squared means there are 2x multiplied together. If I pull out x squared, I pull out x completely, nothing left. If there's nothing left, we cannot leave it blank. When we're doing factoring, if there's nothing left after factoring, we cannot leave it blank. X plus, we cannot leave this place blank. We write 1 as a placeholder. For the second half, x plus 1, there's no common factor. X plus 1, there's no common factor. So I leave it the way it is. When we see x plus 1, there's no common factor. We leave it the way it is. Then we see that x plus 1 is a common factor. x plus 1 is a common factor, I can pull it outside. If I pull out x plus 1, what's left is x squared plus something. You cannot leave it blank. Write 1 as a placeholder. You cannot leave it blank. If I pull out x plus 1, I cannot leave it blank. Write 1 as a placeholder. That's the final answer. Next. Five y minus 5z minus y squared plus yz. 5y minus 5z minus y squared plus yz. When there are 4 terms, we factor 2 of them at a time. Group the first 2 terms together and group last 2 terms together. For the first 2 terms, 5 is the common factor. If I pull out 5, what's left is y minus z. For the second half, delta y is common factor. If the first term is negative, if the leading term from the second half, if the leading term is negative, we need to pull out negative sign. So pull out negative sign. Y squared means there are 2 y's multiplied together. If I pull out one of them, the other one left. For positive y, if I pull out negative sign, positive sign plus positive sign divided by negative sign is negative. If you want to pull out positive sign, positive divided by negative is negative. I pull out y. If I pull out y, there's a z left. Then we can see that y minus z is a common factor. Y minus z is a common factor. If I pull out y minus z, what's left is 5 minus y. That's the final answer. Two xz plus ax plus 5yz plus 20y. 2xz plus ax plus 5yz plus 20y. When there are 4 terms, we factor 2 of them at a time. When there are 4 terms, factor 2 of them at a time. First 2 terms, 2xz plus ax. Take a common factor first. For number 2 and number 8, 2 is the common factor. 2 is the largest number that I'm allowed to divide for both 2 and 8. Letter x is common. Then what's left? If I pull out 2x, what's left here? 2 divided by 2 is 1. There's only 1x. If I pull it outside, there's no x left. Letter z stays. Second term, a divided by 2 is 4. There's only 1x. If I pull out x, there's nothing left. And for the final answer here, if the coefficient is 1, we don't write 1. So 1z is the same as z. For the second half, take out common factor. Look at 5 and 20. For number 5 and number 20, the greatest common factor is 5. That's the largest number that I'm allowed to divide for both numbers. And letter y is a common letter. If I pull out 5y, what's left here? 5 divided by 5 is 1. I pull out letter y. Letter z stays. And we know 1z is the same as z. If the coefficient is 1, we don't write 1. Plus 20 divided by 5 is 4. There's only one y. If I pull out y, nothing left. Then we can see that z plus 4 is a common factor. If I pull out z plus 4, what's left is 2x plus 5y. If I pull out z plus 4, what's left is 2x plus 5y. Next example, 3ab plus 9a plus 4bc plus 12c. 3ab plus 9a plus 4bc plus 12c. When there are 4 terms, we try to group 2 of them together and factor each of them individually. 3ab plus 9a plus 4bc plus 12c. For the first 2 terms, take our common factor. For 3 and 9, the greatest common factor is 3. That's the largest number I'm allowed to divide for both numbers. Common letter is letter A. For the first term, 3 divided by 3 is 1. I pull out letter A, there's no letter A left. Letter B stays. For the second term, 9 divided by 3 is 3. I pull out letter A, there's no A left. So I get 1b plus 3. 1b is the same as b. If coefficient is 1, we don't write 1. Second half, 4bc plus 12c. First of all, take a common factor for 4 and 12 first. For number 4 and number 12, the greatest common factor is 4. And letter C is a common letter, common variable. Letter C is the common variable. If I pull out 4c, 4 divided by 4 is 1. Letter B stays the way it is. I pull out c, there's no c left. 12 divided by 4 is 3. I pull out letter c, there's no letter c left. And we know that 1b is the same as b. Then we can see that b plus 3 is a common factor. B plus 3 is a common factor. If I pull out b plus 3, what's left is 3a plus 4c. If I pull out b plus 3, what's left is 3a plus 4c. Next example, 6x squared plus 2x minus 9x plus minus 3. 6x squared plus 2x minus 9x minus 3. When there are 4 terms, I can factor 2 of them at a time. When there are 4 terms, I can factor 2 of them at a time. 6x squared plus 2x, take our common factor here. For 6 and 2, the greatest common factor is 2. That's the largest number we're allowed to divide for both numbers. Common letter is x. Lowest power is power 1. If I pull out 2x, what's left here? 6 divided by 2 is 3. S squared means there are 2x multiplied together. If I pull out one of them, the other one left here. Second term, 2 divided by 2 is 1. There's only one x. If I pull out x, there's no x left. So I get 2x times 3x plus 1. For the second half, take a common factor first. For 9 and 3, the common factor is 3. If the first term is negative, if the leading term is negative, we need to pull out negative sign. If the leading term is negative, we need to pull out negative sign. Negative 9 divided by negative 3 is positive 3. Negative 9 divided by negative 3 is positive 3. X stays the way it is. Second term, negative 3 divided by negative 3 is positive 1. Now we can see that 3x plus 1 is a common factor. 3x plus 1 is a common factor. So I can pull out 3x plus 1. If I pull out 3x plus 1, what's left is 2x minus 3. That's the final answer. Next, 2x squared plus 5x minus 6x minus 15. When there are 4 terms, we factor 2 of them at a time. When there are 4 terms, we factor 2 of them at a time. For 2x squared plus 5x, pull out common factor. For 2 and 5, for number 2 and number 5, the greatest common factor is 1. For x and common letter is x. For x squared and x, common letter is x. Then we choose the lowest power. Lowest power is power 1. If I pull out 1x, when the coefficient is 1, we don't write 1. If I pull out 1x, when the coefficient is 1, we don't write 1. So only pull out x. For 2x squared, 2 stays the same. X squared means there are 2x multiplied together. If I pull out one of them, the other one left here. For 5x, if I pull out x, number 5 stays there. Now for the second half, take a common factor for 6 and 15. For 6 and 15, common factor is 3. For 6 and 15, common factor is 3. If the first term is negative, if the leading term is negative, we must pull out negative sign. If the leading term is negative, we must pull out negative sign. Then what's left here? Negative 6 divided by negative 3 is positive 2. Letter x stays the same. Negative 15 divided by negative 3 is positive 5. Now we can see that 2x plus 4 is a common factor. I can pull it outside. If I pull out 2x plus 5, what's left is x minus 3. That's the final answer. Next, 6x squared minus 3x minus 2x plus 1. 6x squared minus 3x minus 2x plus 1. When there are 4 terms, we group 2 of them together. We do 2 of them at a time. When there are 4 terms, we factor 2 of them at a time. For 6x squared minus 3x, take out common factor first. For 6 and 3, common factor is 3. That's the largest number we are allowed to divide for both numbers. Common letter is x. And lowest power, with power 2, power 1, lowest power is power 1. If I pull out 3x, 6 divided by 3 is 2. X squared means there are 2x. If I pull out one of them, the other one stays here. 3 divided by 3 is 1. There's only 1x. If I pull out x, there's nothing left. For the second half, find common factor for 2 and 1 first. For number 2 and number 1, the common factor is 1. That's the largest number we're allowed to divide for both numbers. When the leading term is negative, pull out negative sign. When the leading term is negative, pull out negative sign. Then 2 divided by 1 is 2. X stays the same. Positive 1 divided by negative 1. From the second term, positive 1 divided by negative 1 is negative 1. Then we can see that 2x minus 1 is a common factor. 2x minus 1 is a common factor. If I pull out 2x minus 1, what's left is 3x minus 1. That's the final answer. Next, I'll show you a simpler case for factoring. Factoring trinomials. With no leading coefficient. Factoring trinomials with no leading coefficients. Trinomial is a polynomial of 3 terms. Trinomial is a polynomial that has 3 terms. So factoring trinomials with no leading coefficient. That's a simpler case. Let me show you here. It's a simpler case. Trinomial with no leading coefficient looks like this. Looks like, for example, looks like this. X squared plus bx plus c. That's called trinomial with no leading coefficient. Or we say leading coefficient is 1. That's a trinomial with no leading coefficient. Let's look at a simple example first. X squared plus 7x plus 10. X squared plus 7x plus 10. That's a very, very simple case. X squared plus 7x plus 10. When we see a trinomial with no leading coefficient, we first of all draw 2 premises. Draw 2 premises first. First of all, split x squared. Split x squared. X squared can be split as x times x. X squared can be split as x times x. Next, find 2 numbers. Find 2 numbers that they multiply to be 10. Find 2 numbers. When you multiply, they give you 10. When you add, they give you 7. Find 2 numbers. When you multiply, they give you 10. When you add, they give you 7. It looks like the only possibility is positive 2 and positive 5. When you multiply, they give you 10. When you add, they give you 7. So find 2 numbers. When you multiply, they give you 10. When you add, they give you 7. Then next, put these 2 numbers in the parentheses. That's it. That's the final answer. Next example. X squared plus 5x plus 4. X squared plus 5x plus 4. First of all, draw 2 parentheses. When you see a trinomial with no leading coefficient, draw 2 parentheses. Split x squared evenly. Split x squared evenly. X squared can be split as x times x. Next, find 2 numbers. Find 2 numbers. When you multiply, they give you 4. Find 2 numbers. When you multiply, they give you 4. When you add, they give you 5. Find 2 numbers. When you multiply, they give you 4. When you add, they give you 5. The only possibility is 1 and 4. Positive 1 and positive 4. When you multiply, they give you 4. When you add, they give you 5. That's the final answer. Next, x squared minus 10x plus 16. X squared minus 10x plus 16. First of all, split x squared. Write 1x on each parenthesis. X squared can be split as x times x. Next, find 2 numbers. When you multiply, they give you 16. When you add, they give you negative 10. Find 2 numbers. When you multiply, they give you 16. When you add, they give you negative 10. And the only possibility here, we can try 2 and 8. 2 times 8 is 16. But we're going to get negative 10 here. So I can make negative 2 and negative 8. Negative 2 times negative 8 is positive 16. Negative 2 times negative 2 plus negative 8 is negative 10. Negative 2 plus negative a is negative 10. Put in the parentheses. Negative 2, negative a. Next example. X squared minus 9x plus 20. X squared minus 9x plus 20. So, draw two parentheses. Split x squared evenly. Put x in the parentheses. X times x. Next, find two numbers. When you multiply, they give you 20. When you add, they give you negative 9. Find two numbers. When you multiply, they give you 20. When you add, they give you 9. The only possibility here is 4 and 5. 4 times 5 is 20. But 4 plus 5 is positive 9. If you want to get negative 9 here, I make negative 4 and negative 5. Negative 4 times negative 5 is positive 20. Negative 4 plus negative 5 is negative 9. That's the final answer. Next, x squared minus 4x minus 12. X squared minus 4x minus 12. Draw two parentheses. Split x squared evenly. X times x. Find two numbers. When you multiply, they give you negative 12. When you add, they give you negative 4. 12 can be factored as 1 times 12, 2 times 6, 3 times 4. 12 can be factored as 1 times 12, 2 times 6, 3 times 4. The only possibility to get 4 is we use 6 minus 2. The only possibility to get 4, the only way to get 4 is I use 6 minus 2. So for negative 12, I need to use 2 and 6. I need to make 2 positive, 6 negative. Then positive 2 plus negative 6 will be negative 4. Positive 2 times negative 6 is negative 12. So put negative 2 in the parentheses, put positive 2 in the parentheses, negative 2 in the second parentheses. We find two numbers. When we multiply, we get negative 12. When we add, we get negative 4. Next, x squared minus ax plus 15. X squared minus ax plus 15. First of all, split x squared evenly. We have x times x. Then last term is 15. Find two numbers. When we multiply, we get 15. When we add, we get negative a. The only possibility is 3 times 5. But 3 plus 5 is positive a, not negative a. So I need to make the sign. Negative 3, negative 5. When I multiply, I get positive 15. When I add, I get negative a. Then put these two numbers in the parentheses. Negative 3, negative 5. That's the final answer. Next, x squared plus 2xy minus 3y squared. X squared plus 2xy minus 3y squared. Draw two parentheses. Split x squared, we have x times x. Now, if at the end we have variables at the end, if there's variables at the end, we also split this letter. We also split y evenly. Y squared could be split as y times y. If there's letter at the end, we also split the letter at the end evenly. Y squared can be split as y times y. So split the variable in the front, split the variable in the end. Then do the same thing. Last coefficient is negative 3. We try to find two numbers that when we multiply, we get negative 3. When we add, we get positive 2. We try to find two numbers. When we multiply, we get negative 3. When we add, we get positive 2. For number 3, the only possibility is 1 times 3. That's the only possibility. So the only possibility for number 3 is 1 times 3. We try to get positive 2 here. So we can make negative 1, positive 3. Negative 1 times positive 3. When we multiply, we get negative 3. When we add, we get positive 2. Then put these two numbers in the parentheses. Negative 1, positive 3. For the final answer, if the coefficient is 1, we don't write 1. For the final answer, if the coefficient is 1, we don't write 1. Next, x to the power 4 minus 21x minus 46, 21x squared. X to the power 4 minus 21x squared minus 46. So, when there's no leading coefficient, we split x to the power 4 evenly. X to the power 4 can be split as x squared times x squared. If I split x to the power 4 evenly, I have x squared times x squared. Last term is negative 46. I try to find two numbers. When I multiply, I get 46. I try to find two numbers. When I multiply, I get negative 46. When I add them, I get negative 3. For 46, the only possibilities is 1 times 46 or 2 times 23. And we know that 23 minus 2 is 21. 23 minus 2 is 21. So we can try to use 2 and 23. Since I try to obtain negative 21, I make positive 2, negative 23. Then negative 2 and positive 2 and negative 23. When I multiply, I get negative 46. When I add, I get negative 21. So put in the parentheses. That's the final answer. Next, x squared minus 5xy minus 14y squared. S squared minus 5xy minus 14x squared. So when we see trinomial with no leading coefficient, I draw two parentheses. Split s squared. S squared can be split as x times x. Then split y squared. Y squared can be split as y times y. The last coefficient is negative 14. We try to find two numbers that when we multiply, we get negative 14. When we add, we get negative 5. For number 14, the only possible factor is 1 times 14 or 2 times 7. And we know that 7 minus 2 can make 5 here. 7 minus 2 can make 5 here. So I try to use 2 and 7. Since I try to obtain negative 5 here, I try to use positive 2 and negative 7. Positive 2 times negative 7 is negative 14. And positive 2 plus negative 7 is negative 5. Then I put these two numbers in the parentheses. Positive 2, negative 7. That's the final answer. Next, x to the power 4 minus 5x squared y minus 24 y squared. So when we see a trinomial with no leading coefficient, we draw two parentheses. Split x to the power 4 evenly. Split x to the power 4 evenly. I have x squared times x squared. Split y squared evenly. I have y times y. The last coefficient is negative 24. I try to find two numbers. When I multiply, I get negative 24. When I add, I get negative 5. I try to find two numbers. When I multiply, I get negative 24. When I add, I get negative 5. I can try to use positive 3 and negative 8. When I multiply, I get negative 24. When I add, I get negative 5. There's a lot of trial and error. You have to try it out. There's a lot of trial and error. Getting these two numbers, there's a lot of trial and error. You have to try it out. 24, I can try 12, 1 times 24, 2 times 12, 3 times 8, 4 times 6. The only possibility to get 5 is a minus 3. There's a lot of trial and error. You have to try it out. Then I make positive 3, negative 8. When I multiply, I get negative 24. When I add, I get negative 5. Put these two numbers in the parentheses. I get positive 3, negative 8. That's the final answer. Next, x to the power 6 plus 10x to the power 3 minus 24. X to the power 6 plus 10x to the power 3 minus 24. When it's a trinomial with no leading coefficient, we draw two parentheses. Split x to the power 6 evenly. I can make x to the power 3, x to the power 3. If I split x to the power 6 evenly, I can make x to the power 3 and x to the power 3. Last coefficient is negative 24. I try to find two numbers. When I multiply, I get negative 24. When I add, I get negative 10. For 24, there's a lot of trial and error. 12 minus 2 is 10. We try to use 2 and 12. In order to make positive 10 here, I can make negative 12, negative 2, positive 12. Negative 2 times positive 12 is negative 24. Negative 2 plus positive 12 is positive 10. So I can use negative 2 and positive 12. That's the final answer. Next, s squared minus 6x plus 48. S squared minus 6x plus 48. Draw two parentheses. Split s squared. I have x times x. Then next I try to find two numbers. When I multiply, I get 48. When I add, I get negative 6. For 48, you have to try very hard. 48, you can try 1 times 48, 2 times 24, 3 times 16, 4 times 12, 5 doesn't go to 48 evenly, 6 times 8. That's all possibility for 48. Now in all these cases here, 1 plus 48 and 48 plus 1, 48 minus 1, we don't get 6. 24 plus 2, 24 minus 2, we don't get 6. 16 plus 3 or 16 minus 3, we don't get 6. 12 plus 4, 12 minus 4, we don't get 6. 8 minus 6 or 8 plus 6, we don't get 6. So none of the cases works. So we can't find such numbers. We can find such numbers that multiply to be 48, add to be negative 6. That means this problem is not factorable. If it's not factorable, we say this is a prime polynomial. It's a prime polynomial. Or simply say it's a prime. If a polynomial is not factorable, we say this is a prime polynomial. Or we simply say it's a prime.